Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how you can use a graphing calculator to help you verify whether or not a function is even or odd. So before we start showing how to do this on a calculator, let's just review what it means for a function to be even or odd. An even function has the property where for all x in the domain, f of x is equal to f of the opposite of x. And an odd function is a function for which f of x equals negative f of the opposite of x for all x in the domain. So the first thing we're going to do is we're going to check to see if a function is even, right? So I've already got one plugged in. This is a pretty basic one. X squared is definitely an even function, but I just want to verify it and show you how to do this with a graphing calculator. So what I want to do is I want to verify that if I actually use the definition of an even function where f of x equals f of the opposite of x, then when I subtract f of the opposite of x from my original function, if those two things were equal, that should be 0 all the time. So that's what I'm going to define as my y2. I'm going to go to variables, use my first function, apply that at x, and then just subtract my first function evaluated at negative x. Because if those two things are equal, then this second function should evaluate to 0 all the time. Now, unfortunately, this is not a proof that my original function here is even, but if it's not even and it's obvious, I'll know that it's not even. So if I graph this, all right, the red function appears to be 0 everywhere, which means there's a good chance it's even. If I want to prove it's even, I have to go through the definition of an even function and prove that this would work for all such x values. All right, so this is an indication that it probably is even, but I'm going to have to check it. All right, whereas if I change the first function, let's say I make this x cubed, and graph it, notice my red function is not 0 all the time, so x cubed should definitely not be an even function, and visually it's pretty easy to determine that. All right, but x cubed does have a different property. X cubed happens to be an odd function, so now I want to show you how to check that. Recall that the definition of an odd function is that f of x is the opposite of f of negative x. So if I add f of negative x to both sides, then it should evaluate to 0. So all I'm really going to do here is I'm going to change this minus to a plus. If this function is odd, this sum should be 0 everywhere, and I can sort of check it visually. Again, it's not a proof, but if something jumps out where it's obviously not the case, I'll be able to identify that visually. So if I graph this, again, notice that the red function does evaluate to 0. It appears to be everywhere. So this would be a good candidate where you'd actually have to verify using the definition of an odd function that x cubed is in fact an odd function. But when something jumps out and it's clearly not fitting the definition of an even or odd function, then it's a pretty simple case of we'll just find some value of x for which it isn't true. In other words, find a counterexample to show that the function is either not even or not odd. But if you have to prove that something is even or odd, you will actually have to run through the definition of even or odd function to show that it's true for all x in the domain. This is just a good way to spot things that are not even or odd so that you know ahead of time what the outcome should be.